In this problem, we're asked to determine when the population of a particular country will reach 810 million. We're given an exponential model here that we're supposed to use that's describing the population of the country A. So A is the population, and T is the number of years after 2003. So that's sort of saying that if we've got T equals 0, that's the year 2003. So if I had T equals 1, that would be 2004, and so on. So we can start by writing down the model. So A equals 556.5 times e to the 0.015 times t. And we're supposed to determine when the population will be 810 million. So what this 810 million is then, that's what I want A to be, right? That's what the population is going to be after time, right? That's that value A right there. That's the population. So I'm going to plug that 810 million in for A. So 810 equals 556.5 times e to the 0.015 t. Now, I'm trying to solve for the variable here. There's only one variable, that's t. So I'm trying to solve for t in this equation. T is in the exponent. Eventually, how we solve equations where the variable's in the exponent, we often want to take the natural log of both sides. Because if I have the natural log of something to a power, I can bring the power down in front. The problem here is if I take the natural log right now, that natural log would have to go here, right? Natural log of 810, natural log here, and then I'd have the natural log of something times e to a power. And so I don't want this number here. I want e to the power by itself. Essentially what I have to do is I'm going to have to isolate that blue box. I want that by itself. So to make that happen, I'm going to divide both sides by 556.5. So I'm going to get 810 over 556.5 equals e to the 0.015 t, and now I can take the natural log of both sides. So I just do that, and now this exponent can come down in front. When I look at this is going to happen in a lot of these problems. When I look at natural log of e, remember natural log is really log base e. So this really says e to what power is e, and of course that's just going to be 1. So the natural log of e is just equal to 1. That means I don't have to worry about it. And now to get t by itself, I'm just going to divide by 0.015. Be careful, the whole natural log is getting divided. So what I'm going to get then, my t value, is going to be natural log of 810 over 556.5 all over 0.015. Now that's the exact answer for this problem. The directions here don't say what to do with this problem. It might say to take this answer. Oh no, this says use the model to determine when it will be 810 million. So I need to know what year that's going to happen. So I need to know what t is as a decimal. So I'm going to have to do that on a calculator. So on a calculator, there's sort of two types. Most calculators, let me sort of just wall that off here. Most calculators these days act where you hit the natural log button first and then what you want to take the natural log of. And so if that's the kind of calculator you have, to evaluate this expression down here, you would start by taking the natural log. So I do natural log. I'd hit the natural log button. That's going to open a set of parentheses, probably. You're probably not going to have to hit that. It's probably going to do it for you. If it doesn't do it for you, you're going to need that, because I'm going to take the 810 then and divide by 556.5. But I'm going to want to close the parentheses so that that division problem is done before the natural log happens. Otherwise, and then I'm going to do divided by the 0.015, and then equals or enter whatever you have for the calculator. So that's how it's going to work for most calculators. This last parentheses is important so that this whole thing is evaluated before you divide by 0.015. Otherwise, if this weren't there, that division would happen before the natural log would happen, and that would be wrong. Some calculators, you have to enter what you're taking the natural log of first. So for that, when you're evaluating this expression, I don't want to start with the natural log button. I want to get this result in the display before I hit the natural log button. So I'm going to take 810 divided by 556.5 and then hit equals. Then I hit the natural log button. That will take the natural log of that decimal. That's now the numerator of this fraction that we have here, and now I need to divide by that bottom. So divided by 0.015. Now you've just got the 0.015 in your display. It's waiting to see what else you hit. You have to hit equals again to force it to finish that. If you do either of those, what we get for a result is that t is approximately 25.02447. Now in this case, it's very, very close to 25, so I would just say 25. And so we had that t equals 0 was 2003. So if I get t equals 25, I'm going to add 25. And so we're going to get the year 2028 for when this population will be 810 million. As long as we have a number under 26, that's probably going to make sense, because 25 exactly, if this t equals 0 was the beginning of 2003, then t equals 25 would be the beginning of 2028. So even if it was 25.5, that would be halfway through the year 2028. So I would still probably report that as my year.